All right, so for this week's demo lab, you're going to download the demo lab document and then your syntax for it. And then there's a different data set we're using for part one, and then we'll use the general social survey that we've been using for part two. Okay, so as it notes for part one, we're using this world values survey data set. Now, the reason we're doing this is because we're doing a scatter plot. And so what this data set is it's something that Thomas Linneman put together for a social statistics book he wrote. And he took a world values survey data set, which had data set at the individual level that was collected in different countries from nationally representative samples from 2010 to 2014. And he transformed it from it being an individual level data set, right, with 88,000 plus cases to a country level data set. So when you go to the data set, what you see here is that, right, each country is a different row. So, for example, if you go to Civic 1, this is for this country, right? And if we look at the code book, you can see that the country one, it tells you which country based on the code. But like, for example, for this one, so if in the individual level one, a respondent was asked, do you go without a cash income? Sometimes, often, rarely, never. And Linneman said, okay, the percent of respondents that said often or sometimes, that's going to be this variable. And so when we go to that variable, then what we end up seeing, right, is that this is the percent. So in whatever country this is, 21% of respondents said that. In this country, 28% of respondents said that. We could look up the country if we wanted as well with the code book. So this is a country level data set. And we can see that there are 58 countries. And so the reason we're doing this for the first part is because the GSS data set has too many cases where we're going to have too many overlapping coordinates, and we won't be able to see any trends or patterns with the scatter plot. So this way we can make a scatter plot and we can still kind of see what's going on. Okay, so the first thing to do is to choose two ratio level variables from the data set and write a research question regarding them. So ratio level, if we think about a scatter plot, right, it's two number lines on the X and Y axes. We need numeric quantitative type variables. So like this one is nominal, it wouldn't work. Right, categorical ones won't work. Any of the ones that say percent would work. Means, like average number of children, that would work. Something like that would work. Why don't we do, I think this one's interesting, happy. Like the percent of the country that says they're quite or very happy. And then why don't we just do this one too? So sports or recreation group membership. So my question is, does having a higher rate of people in sports or recreational groups increase the overall happiness? Let's see. Do countries with higher rates of participation in sports or recreational groups are countries with higher rates of participation happier? Okay. Okay, so which variable is my independent and which is my dependent variable? So remember, our independent variable is the one that impacts our dependent variable. I mean, there may be no relationship, but as we're thinking about it in terms of the time order, right, the independent variable is the predictor, the dependent variable is the outcome. So here I'm thinking about whether sports or recreation group membership might increase happiness. So my independent variable would be sport membership, and my dependent variable would be happy. Now, you could make an argument the other way. You could say maybe, in countries that have a higher percentage of people who are happy, those people are more likely to join sports and recreational groups, right? So sometimes it's going to be straightforward in terms of which is the independent variable and the dependent variable. And sometimes, just like when you're evaluating causal order, you really have to think through this. What is your research question? What do you think is the right direction? It can be bidirectional, but what is the way it's mostly going? So do I think there will be a relationship? I'd say yes. I chose it because I thought maybe, people who participate more in these things are going to be, more social, and that'll make them happier. So, okay, so I just wrote increased participation in civic life, like sports and recreation activities, can lead to people being feeling social satisfaction and therefore happiness. So I'm thinking that, right, like people in countries where there's more participation overall, there'll be a higher percentage of people saying they're happy, and vice versa. Where there's lower participation, there'll be less. Um, do I think it'll be weak, moderate, or strong? So I don't think this is going to be too strong. I think there's a lot of other things that would impact happiness. And we could think about, like if health was one, you could have countries with a high level of health and low level of health, both having high levels of or low levels of sports participation, right? So I don't think this is going to be the be all end all. I'm going to say I think it will be a moderate relationship. And again, this is thinking about not how steep or substantive it is, but how much it converges into a common linear pattern. So how well could we use rates of participation in sports or recreational groups to predict rates of happiness by country? Then it says, will it be negative or positive? So remember that a negative relationship means that as the IV increases, the DV decreases. A positive is that as the IV goes up, the DV goes up, and then no relationship is as the IV goes up or down, right? Or as the IV goes up, we can just say, right, that there's no pattern, right? Linear pattern where it's not going up or down, right? It's just kind of scattered all over. It's kind of just flat, or bouncing around in a way that doesn't have a common linear pattern. So for this, if I'm saying that as sports membership increases, happiness will increase, then I'm saying that it's a positive relationship because I'm saying as this one goes up, the percent of country that is a member, I'm expecting the percent of countries saying they're happy to go up. So I think it's a moderate positive relationship. Okay, now I'm going to create a scatter plot and add a line of best fit. So here's my syntax. So for my independent variable name, it's sport mem. And my dependent variable name for the y-axis is happy. Right, and I can make sure you don't have to do this every time, but if you're on a new computer or something, right, you can make sure that syntax commands show up in the log. And then I just click play on this to graph the scatter plot. If I wanted to do this with the drop-down menus, again, first I can make sure that that syntax is going to show up in my output, which would be edit options, viewer, and I make sure this is checked and click OK. To make my scatter plot with drop-down menus, I'm going to go graphs, scatter/dot, choosing simple scatter and clicking define. And then my independent variable goes on the x-axis. So that was the sport mem. And my dependent variable goes on the y-axis. And then I just click OK. Okay, so here's my scatter plot. So you can see, like, as we go across, it seems to go up a little bit, but there's a lot of variation here. So now I'm going to add my line of best fit. So this I can't do with syntax. Why don't I copy my syntax, just put it in though. So I have that for this. So there's two ways I can do this. I'm going to double click on it. And then here I can go up to this stuff at the top, the menu, and I can go to elements, fit line at total. Now the default, if you haven't clicked anything else, is linear, which is what we want. If for some reason it's on a different one, you want to switch this to linear. I don't want confidence intervals. And I just click close. Now you'll see it has an equation, which we'll get into linear equations later, and that's covering up to the thing. So I have two options here. I could just kind of drag that. Oops. I can drag that equation over. So if I clicked on it, there we go. I should be able to. There we go. So now it's just kind of out of the way. We don't need R squared at this point. I'm deleting that. So I just clicked on it and clicked delete. Um, so I could just drag this out of the way, and that way when I exit this, you'll see it stays over there and it's not blocking anything. Or if I don't want the equation, I could also just click on that box and click delete, and it'll also go away. Okay, the other way you can do it, if you double click on here, is this little one right here. You'll see it says add fit line at total. So that's the same as going elements fit line at total. So you can also click on this one. It'll bring up that same menu. We want it on linear. Get rid of this extra stuff. I just want my graph with my best fit line. And there we go. Okay, so I'm going to take a picture of this graph and put it into number 4. Okay. So is there a relationship between the two variables? So if this was a flat line, right? If as we went from left to right, as our independent variable increased, there wasn't a discernible pattern, a general trend going up or down. If it was just going across, then there'd be no relationship. But I would say yes, there is a relationship. If so, would you classify it as weak, moderate, or strong? So again, a strong would have all these dots right around the line. A weak would have them have a pattern but be very scattered. This is kind of like the correlation game, though with that you're using numbers, or you can look at those pictures in the chapter. But I would say this is a weak to moderate relationship, right? So if I know the percent of a country that participates in sports or recreational organizations, let's say it's 20%, right? You can see like there's a lot of variation. It could be 15% say they're happy. It could be a majority say they're happy, right? So I'm not going to make amazing predictions. It could be just under 40%. However, I am going to make better predictions than if I didn't know this at all. There is a general trend, right? That as this is increasing, we're seeing this increase as well. Is it negative or positive? Again, as X increases, we can see it's going up, right? There's this general trend here upwards. And so it's a weak to moderate positive relationship. How do I know? Okay. So for the strength, there is a general upward trend. Well, that's for it being positive as the independent variable increases. But there is a lot of variation with the points not really clustered around the line. Okay, so that's kind of how I knew that. And then that's the end of that one. Okay, number 6. Now I need to explain this in real life context. So what does it mean that's a positive relationship? It means that in general, on average, right? So countries with a higher percentage of participation in sports or recreational organizations are associated with having higher percentages of residents who are, it says very happy, quite or very happy. We can actually, why don't we use our templates for this? So that one I was doing the direction. So, right, as this increases, that one increases. So, as countries have higher or increasing percentages of participation in sports or recreational organizations, the percent of residents who are quite or very happy also increases. Okay. Or we could say among countries in the world, right, as recreational sports participation increases, the percent of residents who are happy also increases, right? And then in terms of interpreting strength, we can see there's a template for that as well. Um, and we didn't do that, but I said it was a weak to moderate relationship. So that's like this. So here's my template. So I'm saying there's a weak to moderate relationship between sports recreational participation and happiness. There is an overall observable trend among countries that, and this is the direction. So here we go. As countries have higher percentages of participation in sports or recreational organizations, the percent of residents who are quite or very happy also increases. Oops, I erased. No, that's fine. So there's this overall observable trend, but though there is some variability, right? Because it's not just, right, you go over, you go up. We can see there's variation there. We can make weak to moderate predictions of the percent of a country that will be quite or very happy based on knowing the percent of the country that is in a sports or recreational organization, with our predictions overall noticeably more accurate than if we ignored the percent of the sports recreational participation. Okay, so there's my real life context explaining what I'm seeing here. So if we did a different one, right, so let's just say, let's stick with happiness. Let's see. Let's do men jobs. So this is the percent of the country that agrees that men have more of a right to work than women. So you can see if I did that one, then as I'm going across, is it downward or is it kind of just no relationship? It's either no relationship, it's or a very weak negative relationship. So I'm going to add my fit line. You can see that for every additional percent increase in the country of respondents saying men have more right to work than women, it's going down by like 0.04 in terms of the percent that are very happy. So not much of a relationship, but a very weak negative one. So as this is increasing, there's a very slight, not at all decrease in this. We could look at another one. So this one is freedom of choice. So the average of a country's responses on a scale of how much freedom of choice do they think that people possess? So this was 1 no choice to 10 a great deal of choice. And then those were average. So you're going to have a 1 to 10 that's an average of these. And so you can see for that, actually, that there's a much more consistent pattern. Again, there's still variability, right? So this is a strong, moderate to strong relationship. It's not very strong. It's not perfect, right? If you take countries at a 7 for their average, right, there's still variation. However, you can see these countries are here, whereas these countries are a little lower, a little higher, a little higher. There's some variation. There's some outliers we might want to look at, see like, well, what is this country? What's going on with them? We could find that out or and see kind of what's going on there. But in general, you're seeing a trend here, a moderate to strong positive trend where countries that on average think that individuals have more freedom tend to also have a higher percentage of folks who are quite or very happy. Okay, let's move to part two. So for part two, we're going to go back to the general social survey dataset and codebook, and we're going to continue to use the same syntax file. Okay, so I opened those up, and it says turn on weighting and then generate a correlation matrix with theism and 3 other ratio level or ratio-like variables. So we want to use ratio-like variables. Again, thinking back to that scatter plot, we're trying to show whether it has a linear relationship, and if so, whether it's positive or negative and how strong it is. And so we're going to use theism, and then we're going to choose a few other we're interested in whether there's a relationship or not. So why don't we do theism? Let's look at our code book. We have used sometimes hours last week, so let's do that. And then what things are we curious about, whether there's a relationship between how theistic folks are? This is this individual level data set again. So we need one, like we can't use one that's categorical or that's not ratio, like that's only like 3 category options. We can use something like this, hours per day watching TV. And let's see, we need 3 others. Let's choose one more. So again, we can't use something like region, that's categorical. So something that's like dollars, age, something like this is kind of ratio-like, that's ordinal and has at least 5 categories. We do how often somebody prays. We could do party ID. Why don't... Okay, we'll do this prayer one. Let's just keep in mind, though, for this, that as the variable increases its coding, it actually means they're praying less. Okay. So I want to turn on weighting. If this doesn't work for you, I would suggest closing out of your other data set. This needs to be on the right data set. If you have 2 data sets open, it might get confused. Remember, a weight variable name is just weight variable in this data set. So I turned on weighting. I could also go data, weight cases, find my weight variable, say weight cases by, put it in and click OK. And then where it says make a correlation matrix, you can see I'm just putting in all the variables. So it doesn't actually matter, but I'm going to put theism in first because that way I can just look at the first like column or row to compare theism to the others. Hours worked last week. I had TV hours, and I had pray frequency. Okay, and then I'm just going to click play. You could add as many or as few as you wanted. So if I just wanted to like have 2, I could just run it like that. If I'm doing my drop-down menus, then I'm going to go analyze, correlate, and bivariate. Oh, do I ask you for confidence intervals? Let me see. Yes, I do. Okay, so I'm going to do analyze, correlate, bivariate. I'm going to put my variables over into this. So let's just put these alphabetically so I can find it's theism. So when I tap H, it just goes to the top of the H ones. Or I tap T, I can just go down and find it. And just like there, you could add additional ones with the space. I could keep adding. If I wanted to have more in here, I could add more. And then I want to estimate confidence intervals at the 95%. And means and standard deviations. Do I want descriptive statistics of any of them? I'm not asking you for anything like that. Okay, let's just keep it at that. Make sure this is on two-tailed. This is Pearson. Those are all fine. Show only the lower triangle is just gonna, you'll see that these all have duplicates, and so you can have only kind of half of it show up if you want, but I'm not worried about that. So let's click OK. All right. And did we already do it with the syntax? Did I click play? I don't remember. Oh, I don't have them all here. It was hours last week, TV hours, and right. Thought I had those all there. Okay. So here's my yeah, so the descriptive statistics, if you want to just know for each variable when you're doing the drop down, you can get that as well. I'm not asking you to do anything with that this week, but it's always good to just kind of know about your statistics. That would be option, and you would turn on means and standard deviations. Okay, so let's get our correlation matrix. Let's get our syntax. Let's get our correlation matrix. And confidence intervals. Okay. This one was above that. So it says we're going to interpret this. So we're going to do this 3 times basically. We're only going to look at, from this, we have the relationship between theism and number of hours worked, theism and hours per day watching TV, and theism and prey frequency. We also have other ones. So we have like prey frequency and hours watching TV, right? We can see that that has a non-significant relationship. We can see that praying and number of hours worked does have also has a non-significant relationship. Hours per day watching TV. Let's see. Is there anything else interesting in here? Here, like number of hours worked last week. Nope. Anyway, you could check other bivariate relationships here as well, but we're just focused on the ones with theism for the purposes of this lab. But this has various different combinations, right? This is taking bivariate, it's pairing up all of the different variables. And you can see that there's ones here because like theism and theism have a perfect relationship. Because if you were to think about if you took a scatter plot and you tried to plot it and you used the same independent variable and dependent variable, right? Like in the world values one, if you said, oh, what percent are happy and what percent are happy? Well, guess what? It's 25 and 25 or 70 and 70, right? It's the same thing. And so it's going to be a perfect relationship that they're going to line up on a straight line. Okay, so we're going to interpret this between theism and our other variables. So we're going to do theism and hours worked last week, theism and hours per day watching TV, and theism and prayer frequency. Okay. So first, we're just going to capture data from this table, and then we'll interpret it. So this is where I can write the name. So the first one, it was hours last week. Okay, we can see the p-value. If I look at, here's theism and hours worked last week. So that's the sig two-tailed, significance two-tailed. So it's 0.039. And again, it's the same thing right here. This is theism and hours worked last week. So you can either look at this column or you can look at this row. It gives you the same information. Anyway, so I have the 0.039 and then it says, is there a significant relationship? So this is P less than 0.05, right? Yes. Okay, now my correlation coefficient. So that's going to be this number, negative 0.058. My 95% confidence interval. So for this one, I'm going down to here, and I have to look for the one that has both variables in it. So this is what you believe about God and number of hours worked last week. So here's that same R, same p-value, and then here's my confidence interval around that R. So this just arranged a little differently than this one, where it's listing both of the variables for the pair. So this is the one I'm looking at here. So my confidence interval for that correlation coefficient is negative 0.113, negative 0.003. So actually getting very close to 0, although still significant, right? But we can see the confidence interval is approaching 0. Okay. Strength of relationship. So for this, I would just look at these and find the absolute value of that correlation coefficient. So 0.039 would be, let's see. 0.01, 0.04. So it'd be right here. So that's about 0.04, right? So it would be here. So it's negligible, very weak, negligible. Okay. And then the direction, I'm basically looking and seeing is this negative or positive? And this one is negative, right? It's a negative sign. Okay. Now I'm going to answer, is there a significant relationship using real life context? So among US adults in 2022, there I am, let's see, if P is 0.039, then that's 3.9%. 100% minus 3.9% is 96.1%. So I am over 95%. I am 96.1% confident that there is a relationship between theistic beliefs and hours worked last week. Okay. And then strength and direction. So for this, I'm going to take this. So if I'm looking at this chart, right, then this is how to interpret the strength. This is the story that includes strength and direction. This is the real life context. So I'm basically going to take this template and I'm going to kind of fill in the blanks. So there is, didn't love what that did there. There we go. Okay. There is barely a relationship between theistic beliefs and hours worked last week. There is a very weak, though still faintly discernible trend among US adults in 2022 that, so this is the negative relationship. So as our independent variable increases, so for this again, if we go back to that original template for direction, so we already are saying in this what our target population is, so we don't need that again, but right, as theism increases, so as people get more theistic, and this is going to be decrease, it's negative, right? So hours worked last week decreases. So people worked fewer hours last week. If we try to make predictions of theism for US adults in the sample based on knowing hours worked last week, our predictions are likely to be very inaccurate. Okay, and I could just show you again, if I were to try to do a scatter plot. So let's say I did hours last week with theism. You can see how, oh, that did not work. Not sure what I did wrong there. Let me just put it in here. You can see how I can't tell, right? I really can't tell what's going on. And so that's not helpful to me at all. Okay, so anyway, we did the first one, and now we're just repeating that again for the next two. So for theism, and let me just bring back up my output. Okay, here's my correlation matrix. So now for TV hours. So the name of that variable, why don't I just put in the name of the variable? TV hours, and the name of my last variable is Ray Week. Okay, and then I go here for, again, I could just look at this first column if I want. So TV hours, 0.101 is the correlation coefficient. The p-value is 0.039. Oh, wait, no, I got it wrong. P-value is less than 0.001. hours, yep. And the core, yep, 0.101. And then theism and hours confidence interval is right here. Okay, and then why don't I do this for the last one too? So for prey frequency, it was right here. The correlation coefficient is negative 0.694. The p-value is less than 0.001. And the confidence interval, theism, and frequency is here. Okay, so now I have everything that I need from this output. And so let's just answer the rest of the questions. So is it significant? Yes, P is less than 0.05. Is the direction, so R we can see is positive here. And so it's going to be positive. And the strength, if R is 0.101, then if we look at this, 0.101 would be here. So it's going to be weak. We'll come back to interpret in a minute. This one, is it significant? Yes, P is less than 0.001. Strength, negative 0.694. So again, I'm looking at the absolute value of it. So 0.694. So that's about here, close to here. So moderate to strong, almost strong. You could say moderate to strong if it's in there. You could, I'm going to just write almost strong. And the direction, this one's negative. We can tell from the correlation coefficient. Okay. So P is less than 0.001. So among, why don't I copy and paste this? Among US adults in 2022, I am over 99.9% confident, right? So if this is less than 0.1%, I can do 100% minus that. There's a relationship between theistic beliefs and hours watched per day of TV. And then for this one, it's a same as this one actually. Let's copy and paste that one. It was also less than 0.001, and so it's the same thing, except instead of hours watched, it's frequency of prayer. Okay. So the last thing I need to do is these two interpretations. If I had one that wasn't significant, let's see. Analyze, correlate, bivariate. Let's just add some other ones in that may, let's see, mental health. That's like how many poor mental health days in the past month, phys health, whole views. I forget how trust people is coded. Let's just add let's add age. Okay. So let's see. Well, I was talking about the other pairs weren't significant anyway, but yeah, so here we can see like theism and days of poor physical health in the past 30 days is not significant. P is 0.491. So I would say no in that, and then below, I'd say I am not over 95% confident that there's a relationship between these two. Okay, I don't need to do the actual subtraction and math for it. It's interesting, there is a relationship between mental health and theism, but not physical health and theism here. Okay, so anyway, last two things we need to do are interpreting strength and direction. So again, if I take my direction, template, and we're going to name the unit of analysis or target population. So this is my direction. And then this one was weak. And so I'm going to go to here and use this template. And then this one was moderate to strong. I'm going to use this one. It's almost strong, but it's not quite there. And this has a wide zero point 0.7 to like 0.89. It's much closer to 0.7. Okay, so I'm just going to use that one. Okay, so for the weak one, there is a weak relationship between theism and hours per day someone watches TV. While there is an overall observable trend among US adults in 2022 that, let's see, it is positive. So as theistic beliefs increase, right? So as people believe more in God, um, we're saying TV watching hours, this was positive, also increases. This is positive. So that goes in describe direction of relationship. So while there's this observable trend, there is substantial variability. We can only make weak predictions of theism for US adults in the sample based on knowing hours of TV watched per day. So our predictions will overall be more accurate than if we ignored TV watching frequency. So what we're saying here, right, is that people who watch more TV are slightly more theist or slightly more likely to be more theistic, but there's a lot of variation, right? So like if you watch more TV than me, that doesn't necessarily mean you're more theistic than me and vice versa. But there's this overall trend that is there. And right, it's significant, right? That like we're confident this relationship does exist. Again, we're just talking about strength here, and we're talking about direction. We're not talking about substantiveness or like how steep that slope is. We'll talk about that another week. Okay, last one. So for this one, we had a negative relationship. So as theism increases, right, pray Greek decreases. But this is where this is a little confusing because of the coding of this. So actually, as this goes down from never to several times a day, that means that the respondent's praying more often. So a decrease in the coding actually means they're praying more. So as theism increases, frequency of praying also increases, right? This isn't positive, right? It's because it's this variable goes down, but going down is actually up because of the coding on this. So that's our direction. Okay, there's a moderate to strong relationship between theism and prayer frequency. There is an often consistent trend among US adults in 2022 where as theism increases, frequency of praying increases. So for these, right, it doesn't matter which we think is our independent, though there is a small to fair amount of variability. It doesn't matter which is your independent or dependent variable. We're not arguing whether it's causal or not. We're just talking about the relationship. So it's the same thing as pray frequency increases, theism decreases. As theism increases, pray frequency decreases. Or for like this first one, as pray frequency increases, hours worked increase. That was negative also. Did we do that one? It was negative. Yeah. So hours worked decreased, or as hours worked increases, theism decreases, right? So it doesn't really matter the order of that until you get into evaluating causal order and making that claim. If we look back at our correlation matrix, you can see that again, like theism with hours worked is the same as hours worked. Is hours worked with theism, right? These are the same thing. It doesn't matter the order in that sense. Okay, so back to this last one. We can do a moderately to pretty good job making predictions of theism for US adults in the sample based on knowing how often they pray. So what this is saying is that as people pray more frequently, right, that's associated with being more likely to believe in God, or people who believe more in God are more likely to pray frequently. And again, it's not saying how much that increase or decrease is, but that, if I know how often you pray, I can make a pretty good prediction of how much you believe in God or not, and vice versa. Um, but there's still some variation, right? So people might have the same theistic beliefs and one prays more, one prays less. People might pray the same amount and one believes, one doesn't believe, etc. So there's still some variation, but that overall there's this general trend that we can see from this correlation coefficient. And we know its direction and its strength, which is going to, again, how good we can do at making predictions, how well it converges into that common linear pattern.